Right. We'll see the clustering today. I'll see how WebLogic handles clustering, and even before how WebLogic does it. We will see why we need clustering in general, or the general concept of clustering, and we'll see what are the things that can be clustered in WebLogic. And as we move into other sessions like JDBC and GMS, we will see how those components can be clustered. We will see clustering in terms of managed servers at this point, essentially to handle the load that is coming into an application server. We'll see the structure of how a WebLogic cluster handles load. So in general, a generic cluster, any generic cluster, normally a group of similar things, when we combine together, we try to achieve some kind of high productivity, it's not necessarily always the same kind of productivity we try to achieve, but depending on the scenario, we try to achieve different things. Now if you take, for example, I given two examples here that are kind of clusters. A double-decker bus kind of thing. In a double-decker bus kind of thing, we have two layers of two layers where people can actually sit. So we are doing that to accommodate more number of passengers. So that's kind of a very simple cluster kind of thing. But the target here is to handle more number of passengers. Now a train which has let's say two engines at both ends. Now the one purpose of such mechanism would be to, if one engine fails, the other engine would be able to take up the system uh, to the point where it can be repaired. Now this two engine train has obviously other purposes also, that you are going in one direction, you use one engine, you are going the other direction, use the other engine. But that's also another usage. But we are looking at the usage where one fails, the other engine will take up the responsibility, or other engine will handle the things. So this is again a clustering, but in this case, unlike the double-decker bus where we are trying to handle more load, a two-engine train, it's not handling more load. The load is still going to be same, but it is giving the train a high availability. Means the moment you put two engines in a clustered mechanism, or a very simple thing, a cluster combination, we have a train which is highly available. That's what we are saying. Now when an engine fails, your train system or the system moves on to the second engine, or it fails over to the second engine and then continues to run. So the second thing here, if you see, that's what's happening is the train will the engine will fail over to the second one, thereby the entire system is highly available. So as a general concept of clustering, or a relationship between failover and high availability, you implement failover, you achieve high availability. That's how the two are related. They're not two different things. One is what you do, other one is what you get. High availability is not something that you implement failover to achieve high availability. So in this case, we are implementing failover of engine from one point to another point, we achieve a highly available train. That's how those two are related. We commonly come across this term, failover, high availability. They are related to each other. They are not two different things. They are not two similar things either. They are related. It's kind of, you implement failover, you achieve high availability. Now in general, any clustering if you take, it tries to achieve some of these things like scalability. You have ability to scale up to certain level, but that's you add similar components more and more and more so that you can handle more amount of load. That's one reason why we want to do clustering sometimes. The second thing is load balance. Load balancing is what we have seen in the double-decker bus example. You balance the load. Let's say if you have uh, one single bus that probably is handling 100 passengers, another adding another compartment probably would add another 100 passengers. So that way you can handle the more amount of load. Now in WebLogic, when we come across the load balancing thing, I'll show you an architecture. The load balancing is not really handled by WebLogic itself. It's outside WebLogic. We have a load balancer or we have a Apache server, that kind of. Now the third one is why we implement WebLogic cluster in general, a highly available system. Now we achieve high available system by implementing the failover. As I said, engine 1 fails, we fail over to engine 2, we have a highly available train. The same way, a managed server 1 fails, we switch over to managed server 2, so we have a highly available WebLogic. I'm going to show you that architecture. So these are three commonly tried things when we have when we are trying to implement a cluster. We may want to get a scalability of the system, we may want to balance the load on the system, we may want to achieve high availability. Now in WebLogic's case, it's the third thing we are trying to do. The first two things are not really what we are planning, or what are they're not the ones that we have in our mind. You can scale up WebLogic even without clustering. You can simply add managed servers. So scalability is not because of clustering. Load balancing is never done in a cluster. Load balancing is done outside WebLogic altogether. High availability is what is done by a cluster. You will get it in a couple of minutes. Now let me show you. Look at this scenario here. So here we have right. So this is how the user is accessing it. If you take it on this side, probably they land on some router. Then the load balancer, after the firewall, let's say they land on a load balancer. Now when a load balancer receives a request, it simply passes it on to the available destinations, assuming there are 2 or 3 servers. Alright, then all of them will be passed on to equal number of requests. So in this case, if there are 100 requests, then each of the managed servers will get 33, 33, 33 kind of thing. So that's a simple load balance. If you observe here, WebLogic is not doing this load balancing. The load balancing happens outside WebLogic. It does not really matter whether these servers are in a cluster or they are standalone servers. It does not really matter. So load balancing is not something that we are trying to achieve using WebLogic. Look at the next scenario. So if you see, the load balancing is usually achieved by an external agent here. If you see, it can be a hardware load balancer or it can be a software load balancer. Normally a hardware load balancer is one of these things that we usually try to do, especially the F5 load balancer. That's a popular one nowadays. This one. Then when it comes to software load balancer, you can use a web server like iPlanet or Apache server. Now we have to configure the web server with what is called a proxy plugin that gives the load balancing capability. Now this is a C based or a C language written load balancing. The same way we can write a Java based load balancer, kind of a servlet, a very simple servlet. A Java based load balancer, again this is also software. The Java based load balancer is kind of what is called HTTP cluster servlet. It also has a very simple logic. If I receive 10 requests and if there are 2 destinations on the other side, send 5 each. It's a very simple load balancing logic. Now if you observe, in general you will come across either hardware load balancer or a software load balancer or both most of the times. Means first the request will fall on to the hardware load balancer, then the hardware load balancer will redirect it to a series of web servers. The series of web servers here will serve the static content. If there is any dynamic content, they will again load balance it among the available application servers. That's another common scenario we'll see. Now let's see here. So you got a hardware load balancer. In this case the same thing. So this is hardware load balancer. If it is not hardware load balancer, instead of hardware load balancer you can replace this area, this hardware load balancer, with a software like a web server here. So we have a web server and then we add what is called a proxy plugin. Now this proxy plugin will be provided to you by Wl06 application server itself. Now we have to configure this proxy plugin so that the web server knows how to send the request to the backend destination. So here we got a web server, a proxy plugin. We are attaching the proxy plugin to the web server. This one. This is something that we add usually. Now this configuration we will see in our Apache configuration, how to integrate Apache with Wl06. That's something we will see. Alright, and this in general is one architecture where only web server is there, or ideally what we can have is a series of web servers. Like if you see here, you will have a web server here, another web server here, another web server here, probably 3 or 4 web servers like this, and then in front of these web servers you may have a load balancer like this. So the load balancer will redirect it to the app servers, to the web servers, and the web servers in turn are configured with the proxy plugins here. Alright, so they will be here, they will have a proxy plugin. All of these web servers will have a proxy plugin. We will have to configure that one. Then the proxy plugin will be used to contact the app servers. All these proxy plugins are configured for to send the request to app servers like this. So here I have here, and then this proxy, this thing is configured to send here, send here, send here like this. Same way this one also, everywhere. So every proxy plugin or every web server can send it to any of the backend destinations. That way, even if one of them is down, like let's say this the first web server or first 3 web servers go down, assuming so let's say here this is down, then this is down, you will still have one web server, which is this, that can still redirect to this one. Still, it can still redirect to any of the managed servers. So that way, a hardware load balancer plus a series of web servers, then a series of app servers, will help in separating the static content from dynamic content. That's a typical architecture you would see in all environments. Now the web server here can be either Apache web server, or nowadays you will see OHS being used all locations, because OHS is, again, it's built on top of WebLogic. OHS is built on top of Apache, so it's pretty much same as Apache. All capabilities of Apache you have, and there are certain enhancements, and obviously Oracle support. So that's what makes OHS much attractive than Apache. So now the same thing, same web server can be implemented in any programming language. So Apache web server does it in C. Instead of C, you can write a Java program. Now the Java program is what is called HTTP cluster servlet. This is the HTTP cluster servlet. Is a Java program that simply redirects. Now because that's a Java program, obviously you will be deploying it onto a WebLogic server. So here we have two things. So if you see this one, so this is what your HTTP cluster servlet is. It can be deployed to a WebLogic. Again, the WebLogic will, all the requests will be received to WebLogic, and it will simply redirect. Here, this kind of architecture is not very stable architecture, because the WebLogic, a standalone or single WebLogic server, may not be able to take up all the load. So, and in that case, what we have to do is, we have, just like a web server, we have to do a series of WebLogic servers with the HTTP cluster servlet to handle the load. And rather than using WebLogic servers as a front-end layer, we usually go for a web server, which is the previous architecture that we have seen. This is more like a theoretical setup, HTTP cluster servlet. It's never really used, but it can be done in case if we need, or if you don't want to put Apache, or if the project is very small or internal project kind of thing. So load balancing, majorly you will see hardware load balancer, web servers, proxy plugin, WebLogic servers. That's the architecture you will see most of the times. So load balancing, when we see, it's WebLogic is never really involved in load balancing. By the time the request reached WebLogic, it's already balanced. So what we are trying to achieve when we think of WebLogic clustering? Here we are trying to achieve what is called high availability. Now let's see how we achieve high availability. Now in general, when we call highly available a system is something went wrong inside the system and the end user does not know about it. They are able to continue that request without noticing any interruption. So the system internally handled that failover. One part of the system failed, the other part of the system handled that failure. It's transparent to the user. That's what is called a highly available system. And we achieved that highly available system by using a failover mechanism. So what we are looking at here is, if my managed server fails, this one, alright, in the middle of a request, let's say a user is connected to one of the managed servers, that managed server failed for some reason, or we have killed it using kill-9 command, the end user should not receive an error message. Our group of WebLogics should handle that failure in such a way a request is continued on the next server. If we can do that somehow, we can say our WebLogic is highly available. or our Wl06 cluster is highly available. Now let's see how Wl06 implements that failover mechanism. Now this is what normally happens. A user is accessing your application. Now they probably are using some kind of browser or something here. So once they start using a browser, they fall on the router, then the load balancer. Let's say the load balancer has routed the request to this server here. So this is a server which is handling the request initially because the load balancer routed it here. Now assume that server was killed for some reason. Now the server is killed. Now when the server is killed, obviously the HTTP session which is corresponding to that user request will be gone. Now if we have to fail over, all that we need is that HTTP session which is not there. So if you see this one, in this case, because the managed server which is holding that request or which is handling that request went down, ideally the end user will receive or it should receive some kind of error message. Now this is what we don't want. When the managed server fails, the session, HTTP session information which is on the managed server should be stored somewhere so that we can use that HTTP session information, continue the request without the knowledge of the end user or without interrupting the process of the end user. Now, which means all that we need is the HTTP session information to solve this problem. Now let's say we take the HTTP session information. Now come back to the beginning of that request. User accessed through a browser, comes through a router and falls on the load balancer. The request is landed on managed server 1, encode mng1. Now before encode mng1 responds back to the browser, the HTTP session, it will try to store it somewhere like a replica. Now the second location where we are storing that session is called a secondary server. So all that we want is the HTTP session information. So the primary is based on the load balancing algorithm. Load balancer simply sends it to one of the servers. That one server becomes the primary. So encode mng1 is the primary here. Now that primary, before responding, will choose a secondary where the HTTP session can be stored. We are simply looking for a backup copy of encode mng2. Why we want a backup? In case mng1 goes down, mng2 should be able to continue that request from that point onwards. Now here, if the first one failed, the load balancer will simply redirect the request to the second server. Now the question is, how does the load balancer know which is second? Now let's go back one step further. Let's go back here. mng1, this is the primary. The first time request landed here. It chooses secondary. That's where the replica is stored. So we know primary and secondary now. Now the information of primary and secondary will be sent back to the browser actually. So when the managed server 1 responds, it will be sending out the information of both primary and the secondary in the form of what is called a cookie. So the cookie will have primary, it will have secondary information. About this information will be with the browser, and whenever the browser is responding back, it will also give this cookie information in the request. From that point onwards, the load balancer will look at the cookie. If the load balancer is looking at the cookie, the load balancer knows which one is primary and which one is secondary. As long as primary is available, it will send it to the primary. If primary is not available, it will send it to the second, which means all that the cluster is doing is replication. Who is redirecting the request? An external agent, load balancer again. So in this case, a WebLogic cluster depends on the load balancer to do the redirection. All that the WebLogic is doing is it finds a secondary server, makes sure a replica is available on the system somewhere, and the information of both primary and secondary will be sent back to the browser. Browser will send that cookie every time the request is made, every time a new request is made. Now every time a request comes into the load balancer looks at the cookie. The cookie will have primary, and load balancer checks whether the primary is live. If it is alive, it will send it across. If it is not, it will send it to the second. Now if you observe here, there is a slight what we call deviation from the regular load balancing algorithm. Normally if there are 3 requests coming from a session, let's say here you have let's say you have a session. This session may be sending multiple requests. Now first time when a request is made, the primary is, let's say this was decided as a primary. This server shows secondary as this server. The information of both of these has been put into a cookie, and the cookie was sent to the browser. So now you have a cookie with the primary information and then secondary information. Now next time when a request is made from the session, it lands on the load balancer, alright, and then the load balancer means this is the second request. The load balancer is ideally supposed to send the request here, or based on the load balancing algorithm. But what happens is, because it's coming from the same session, it will send it to the primary server here. Sorry guys. It will send it to this primary server, this one. We're looking at, let's say, the third request. There are 3 requests coming in. So I'm saying the first request went to the managed server 1. Managed server 1 shows managed server 2 as secondary server. The information of both of these 2 things was sent back as a cookie to the browser. Now request 2 came in. When request 2 comes in, where should the load balancer send it ideally? It should send it to second one. But what the load balancer does, because the request is coming from the same session, the load balancer will bypass its load balancing algorithm and it will send it to the first server itself, because the primary is available. Now let's say the third request. Means we have 3 requests on the system now. If there is a third request, where should the load balancer send it? To the third server. But it won't send it to the third server. Because the primary is available, it will still send it to the primary. In this case, what is happening is, all the 3 requests, because they are coming from the same session, are landed on the same managed server. Even though the load balancer is supposed to distribute the requests among first, second and third managed servers, it did not do it. Now this property of sending all the requests from the same session, they are all coming from this session, onto same primary server is called session stickiness. Now the session stickiness has the advantage that you don't have to recreate the entire session. If you see it here, we have to recreate the HTTP session always. This thing. Now if we send it to the existing server, we don't have to recreate this entire session. So that way you will achieve a little more performance. So this property of sending all the requests from one session to the same primary instead of distributing it across the managed servers is called session stickiness. Now in all the WebLogic implementations, the load balancer usually implements a session stickiness. That way, anything coming from the same session will land on the same primary. The secondary will be the one that was chosen at the initial first request. So by replicating the HTTP session, what we are doing is we are acquiring the capability to failover. Means when the first encode MNG1 fails, the primary fails, the load balancer simply redirects the request to the secondary. The end user will not have any information about it. Now the question is, how much or what percentage of this transfer is possible? Normally means, is a failover 100%? That's a normal question we are asking. A failover is not always 100%. Means it's not possible that we can continue all the requests from the point they have failed. Let's say there is a transaction, database transaction in between. Now you cannot continue the database transaction from that point onwards. It's not possible. Database does not allow such failover. In that case, the connection will be terminated from the database. We have to establish a new connection. So failover in any system is not 100%. We try to achieve maximum 98-99% of the failover, but there are always certain number of requests where it's not possible to failover. So in that case, the user will receive an appropriate error message. But a general HTML session can always fail out because there is no harm done in redoing the transaction. So read-only transactions are the easiest one to fail out because simply you reprocess the information, send it back to the user as if nothing happened. The user will not know anything about it. Now this is a common way of implementing the HTTP session replication in WebLogic. This is called HTTP session replication, and because we are storing the session in another JVM, we call it in-memory replication. That's the first type of replication available in WebLogic. In-memory means within the memory of another JVM, we are storing the replica of your HTTP session. Now as opposed to in-memory, you can have a DB based replication. Means you don't want to store it in a database, but you want to store the HTTP session in you don't want to store it in another JVM, but you want to store it in a database somewhere here. Now once you store the database, there is no secondary server concept in that case. So whenever the primary fails, the load balancer can simply redirect the request to any of the managed servers. Now all these managed servers can go to the database, pick up the HTTP session, continue that. So that way it is much easier because you don't have secondary. So either you have a memory or in-memory base. Isn't the default behavior of WebLogic server sending requests to the same thing? What is the question? It's not the WebLogic server which is sending the request, right? It's the load balancer. WebLogic is never participating in distributing the request. We got the point. Who is sending the request here? It's the load balancer. Right. So WebLogic has no role in distributing the request at all. It simply acts on a request. Now the question is, isn't it load balancer's common property that it should send all the requests from the same session to the same managed server? That should be the question. WebLogic is never participating in distributing the load. It's only replicating. Now that, as you asked, either way, no, it's not either way. It's always the load balance. Yeah, okay. If you are okay with that point, the load balancer, it's not by default. Load balancer does not by default send all the requests from the same session to the same manager. We have to configure that property. That property is called HTTP session stickiness. If you don't configure that property, the load balancer will simply divide the requests into 3 managed servers here, even if they are coming from the same session. The next page what you are seeing. So here, even if they are coming from the same session, if you did not configure the session stickiness on the load balancer, all the requests will go to different servers like this. Now that's not a default property. The session stickiness is not default property. It has to be configured in the load balancer.
No, Anil. So I'm a bit enthusiastic to know. So we say always the web advantage of WebLogic, like we can provide the high availability, scalability, and failover using WebLogic server. Any kind of application server you take.
Right.
But so you are saying that there is no role of failover and load balancing managed server here. I mean WebLogic server here.
The failover itself is not done by WebLogic. It provides all the infrastructure so that we can fail over. See, we cannot simply fail over if WebLogic does not do the replication. You see this one? Let's say here, WebLogic did not do any replication. In that case, even if you are failing over to the second server, what's the use? So your statement that WebLogic provides high availability, it's valid. It's WebLogic who is doing the replication. The replication part is handled by WebLogic, but somebody has to redirect the request. That's usually an external agent, something like a load balancer.
So let's say I don't have any load balancer or any third party mediator. Is there
Then
any
you can have
default behavior of WebLogic? Any default behavior of WebLogic having this kind of features?
So who is doing the load balancing in that case? You can have a HTTP cluster servlet which can do that for us. The HTTP cluster servlet is again deployed to WebLogic. So even though you are saying we don't have a load balancer, we are implementing a load balancer based on HTTP cluster servlet somewhere here. They will be deployed to WebLogic. The HTTP cluster servlet will do the same thing as a hardware load balancer does here.
Okay, in
that
any
way
case, we need to have one more layer.
That's right. In any case, the request has to be divided before it reaches WebLogic.
Okay.
That common architecture is what you have: a load balancer, web servers, and then app servers. That's a very common architecture you will see in all the environments. Now that has two purposes.
In any entire architecture.
Yeah, in the entire, you will see that 99% of the cases that has two advantages. The load balancer will distribute the load. Web servers will take care of static content, and then they will distribute the dynamic content across the managed servers.
Okay. So if some scenario like the other layer, the web server layer goes down, or something happens, it's unable to redirect to the manager server. So
yeah, you have a problem. Yes, that's why you have multiple web servers. After the load balancer, we have multiple web servers here. So each of those web servers, so even if some of them go down, you have it in such a way that others are still available. If you say all of them went down, then sure we have a problem. If all of them go down, we have a problem.
Okay.
Alright, so moving on. So failover here, or a high availability here, we are achieving by storing or replicating the session either in memory or in the database. So either you have in-memory replication or DB based replication. If it is in memory, you have primary secondary server concept. If it is DB, there is no secondary server concept. Anything can be secondary. The secondary will pick up the HTTP session from the database. It will continue. Obviously the question is when you will use in memory. Yeah.
Yeah, I think you were answering, but in between I interrupted. So if we go with in memory, the first one, you have the concept of primary and secondary. So if we take the current example that you have in front of us, the manager 1, 2, and 3, if we take the secondary example, then manager 2 is as if not available to the public, because it will always be trying to replicate whatever is coming to manager 1. So truly speaking, the load balancer will never be redirecting the new requests, new session requests to manager 2, because
Why?
manager 2 is always a standby.
Why?
Is because the way I understand it, say first request comes, it goes to manager 1, right?
Okay.
So when it goes to manager 1, it gets replicated into manager 2 also. So
Okay.
though from the outside world one request has come, but in terms of the load, manager 1 has one request, manager 2 also has one request. So when the second
No.
request will come, it should go, the fresh session should go to manager 1 again, because both have one requests each. Sorry.
No. Load balancer does not count that replica as load. Load balancer counts the incoming requests. The replication is not the load. It doesn't consider it.
But then it is not the right. See it in the terms of the load also. Now let us see it as load. Okay. So let us see as MB memories. Okay, in JVM. So the first request comes.
I'll tell you what's happening. Encode managed 1 is copying the content to manage 2. Apart from copying, encode managed 1 processes your request. That is where the load is coming. Storing HTTP session itself is not load. You're putting something in your memory, you're keeping idle. That's not load. MNG1 keeps the HTTP session, then it goes to CPU to process it. Let's say there is a database connection, it goes down there and connects to the database. There is a Java code, it executes it.
Okay, then.
That part is not happening on
Understood.
MNG2.
So let us take that scenario. Okay. That is, I only have two managers, 1 and 2, just to keep my illustration easier, my question easier. So manager 1 gets 10 requests, and manager 2 also gets 10 fresh requests. Okay, so both have 10 each, and one request is being replicated at 2, and 2 requests replicated at 1, right? So each is serving 10 requests, and 10 are just stored as a secondary, right? Replica.
Right.
All of a sudden the manager 1 goes down. Okay. So now the manager 1 is serving 20.
Right. That's right. Right.
So the moment it is serving, it is addressing 20, it will go down, because now the load is too much upon 2.
Yes.
So when the 1 goes down, then the 2 is not able to cope up with the load.
That's right. That's right. That's correct. That's perfect.
So if
that should be taken up in your capacity planning.
I say.
That's what we do in capacity planning.
Great. So now let me put my example differently. So in that case, what I should have done in my design, forecasting this, I should only keep maximum 5 requests in my manager 1 and 5 in 2. So that if one fails, the other can take over. Which means that I have to keep them 100% redundant.
Right. That's right. That's right. That's right.
Which basically goes down to my very first argument. It is better that the managed to servers is always ideal. Why? Because then when the manager 1 has 10 requests and manager 2 has only the second return request doing nothing. If one fails, it will go to 2, right? It's the way you look at it. It's one and the same thing then.
Yes. Yeah, you can say it. You can, as if you are keeping it idle, but instead of keeping it idle, we distribute the requests on both of them and let them do half of the work, kind of.
You know what? Yeah, as I'm talking to you, I think I got my answer. If we go with 10 with one guy and the second is empty, then the first guy is loaded and responds slow. It is better off we put the 5 on each, so that in a general scenario they will perform better.
Right, that's right.
Yeah, I think I got the answer. Okay, good. Thank you.
Right. So again, when we use in-memory versus when we use DB, as you've seen, in-memory has obviously the secondary copy in another JVM. Now, obviously, we have the danger of the second JVM also going down, in which case your failover will not be happening. Manage server 1 failed, manage server 2 where the replica is stored also failed. Obviously, you don't have anywhere else to fail over to. Means in the scenario where both primary and secondary fails, our solution fails. In that case, a database would be much more appropriate. Means, let's say the client says, at any cost I want the failover. Means a failover is guaranteed. In that case, a better way would be to store the HTTP session in a database. A failure of a database is relatively less because you have rack and a lot of other technologies that can actually take care of near 100% availability. So Oracle database or any other database, if we are storing the replica, we can say guaranteed failure or a permanent availability of HTTP session. Even if the database goes down, kind of I don't think database going down scenario is appropriate, but assuming database is highly available, a rack kind of thing, we have a very, I can guarantee it into a 100% level that yes, we can fail over to a new server. The problem with a database storing is obviously it's going to be slow, because if it is in memory, we're going to store it within the JVM itself, which will be picked up from the RAM, whereas the moment you put it into the database, you are touching the hard disk, which eventually will slow down your request. So in memory versus database, in memory is faster, database is permanent or guaranteed failure. Now, depending on the customer's requirement, we choose one of these two, or we can actually implement both of them if possible, but that will complicate the design. Usually you will go for a in-memory replication, which is faster, which will not have too much performance kind of sacrifice. But again, it depends on the customer's requirement. The customer says, I need the failover at any cost, even if it is slow. Yes, we still have that one. From a technology perspective, you can put the HTTP session in the Oracle database. Now the session replication implementation, now what we usually do is it has to be coded in the application, as well as some settings have to be done at WebLogic level also. Means session replication is not just a WebLogic feature. Means if the application itself is not designed to replicate, WebLogic cluster simply cannot start failure. Means just by creating a cluster we cannot replicate. That's my point. It has to be coded in the deployment descriptor of the application. A deployment descriptor, in this case weblogic.xml. There is a parameter persistence type. In that case you are say replicated. That is a part of development wherein the developer or our architect will decide that this application has to be clustered. So application code should have the code for failover, and then we have to create a cluster so that the code gets replicated to a clustered server. So it's job is from both ends. The developer has to code it so that it can be clustered. An admin should create a cluster so that the HTTP session goes to another server. It's a both end job.
Okay.
Yeah.
Anil, let's say I'll take simple example, a shopping cart application. So like I go to the catalog, product catalog, and I choose and two products, and so I have done all the things and gone to the shopping cart. I see the two items in the shopping cart. So and I could see the one manager server is serving that request in the logs. Okay, let's say I made it down the server which is serving this request, and again I gone to the catalog and I have chosen two more products, and again until it goes to the shopping cart, I could see the four products. So as you are telling, we need to replicate it in the weblogic.xml. So that means, so we need to have two categories in the. So how many context we need to have in our deployment descriptor in this case?
How many contexts? No, I'm not really sure about that part. The Java part, I'm not really sure how it is actually, the shopping cart is implemented. I don't think you have, two contexts. If you are saying you are in the shopping cart,
So how
you
it will
selected
be.
two products. Obviously, the two products are in the HTTP session replicated somewhere else. Now you are browsing through your website. You sent, you clicked on something else. The request went to the load balancer. The load balancer realizes the primary is not there. It will send it to the secondary, which already has two items in the shopping cart. It will simply add the third one.
My question is like that.
This is a stateful bean, isn't it? A
No, no.
stateful bean or something
How
that you
many
implement.
servers? How many servers we have? That much context we need to have in the deployment descriptor. In this case, like so, manager server one goes down. It should replicate it to the manager server two.
Okay. The context will
Like
be only
that.
one, right? That will be replicated across the managed servers. Your context is still a single context. The same information is available on all the managed servers, or at least the secondary managed server.
So how the request knows the manager server one is goes down
It
and
won't
it
down.
should
It
go to the
won't know
manager.
it. The requester will not. That's the point of doing all this thing, isn't it? The requester should not know anything about it. It will be given a cookie. It simply sends that cookie back. The load balancer is the one which sends it to the secondary.
That's right. The same context should be there in the manager server too. Somebody
Yes.
needs to redirect to the manager server two when in case of manager server one goes down.
The load balancer. The load balancer redirects it to managed server 2. You see it here? Your context was initially in managed server 1, encode mng1. Now encode mng1 failed. The next request, when you clicked on the third item, came to the load balancer. Load balancer realized, okay, first one is down. It sends it to the secondary where the replica is available. It's the load balancer who is doing the redirection.
Okay, there should be some kind of mechanism in the load balancer. I want to know that mechanism, how it will redirect.
The cookie. It uses the cookie. A load balancer looks at the cookie that it received from our session. It looks at the cookie, and the cookie information is primary and secondary. It simply looks if the primary is available. If the primary is not available, it sends it to the secondary. That's part of your session stickiness properties. It's all part of the session stickiness properties. You can do one thing, Chana. There are software load balancers, like there are certain properties. Yeah, Deepak.
Just a second. See, Chenna, what happens is the people say that WebLogic is totally clusterable and fail safe, high available, but there are always some components that you have to put along with the WebLogic server to make it that way in the real scenario. That is one. Coming back to your specific question, you have to have what is called as a hardware load balancer. That hardware load balancer as a piece of software using which you basically configure. Okay, you configure that how it is going to function along with the WebLogic and the Apache server in between. Apache server layer is very, very thin, as if it is not even there. What it is doing is just doing a handshake between the hardware load balancer and the WebLogic managed server. It is kind of a facilitator or a modulator between the two. Again, coming back to the hardware load balancer, when you are configuring, in there you put all the required information, which is GUI based and nowadays very simple even. That this is the server names or whatever I want to give, and that is the way it is going to look for the failed connection. If I go in terms of software code, you can imagine it is as if go to manage 1, if no response in the exception, go to managed 2. That's all it is. And instead of writing the managed 1 name and managed 2 name, they are passed as variables. Those variables are stored in the cookies, and that's what this load balancer stores in it. I don't know if I am able to explain that to you properly, but this is my understanding.
Oh, okay. Yeah.
Does it make sense? In fact,
Yeah,
it
it
is
makes
so
sense.
much so that in a practical scenario, you even put 2 hardware load balancers. So you put 2 physical load balancers, 2 pieces of hardware. Okay? Why? Because even the load balancer can fail itself. So you are doing the clustering, which is fantastic. So what you are doing is you are putting 2 servers, physical servers. One is your WebLogic server 1, second is your WebLogic server 2. In the first one, you have the admin servers and 5 managed servers. In the second one, you have 5 managed servers, right? So if one server goes down, no problem. Second is there, you will take the load and everything will work fine. And both will have the Apache also, you are good. But what if the hardware load balancer itself fails? So for that reason, you will have that also redundant, that is 2 instead of 1. Does it make sense?
Yeah.
Yeah. Sorry,
Thanks.
sorry, Anil.
Yeah,
I
yeah,
thought
that's
I
fine,
just,
that's fine, that's fine, that's fine.
sorry about that.
Chana, you are satisfied?
Yeah.
Okay. Oh, yeah, it looks like you are under the assumption WebLogic does everything for us. It could not.
Okay.
It could not do everything without the help of
But also one
the
thing,
other elements. Yeah.
one thing, Chana, Anil is extremely good. This is the first class I am taking from him. I also come from a background of software, hardware, and all of that. But he is very, very thorough. He is very, very good. I'm saying it. And Anil, I mean it.
Yeah.
You
Thank you. Thank you.
you know things inside out. The way you explain. Of course, you cannot know everything. You can only know your domain, right? But
Yes.
you
Right.
seem to be really an expert in your domain. And you know what? I'm very happy I'm attending this class.
Thank you. Thanks so much.
Thank you. Thank you.
Okay. Chana, shall we move on?
Yeah.
Yeah.
Go ahead.
Okay. Cool. So let's move on further. Okay, so we got this in-memory versus database replication. Depending on the customer requirement, we go ahead and set up our things. Now, when we are setting up cluster, there are certain points related to WebLogic that we usually keep in mind. Now creating cluster. Now, this all the thing that we have talked so far are happening inside. Now, creation of cluster or implementation of cluster in WebLogic is pretty simple. All that we have to do is we create a logical name, we add couple of servers to it. That's it. Our job as an admin is pretty simple when it comes to clustering. Let me show you that part, and then we will come back to these points again. That way it will be much easier. So I'll connect to our cloud server, and then we will create a cluster. So let's go to our allocation, cd students line pa user projects domains encode daemon, start our admin server, tell it, launch the console in the meantime. As Chrome is really slow, so I'll be launching it in the Opera. 192.168.128.6 with 20,001 port. That's our admin IP port. So admin server is already up. This one, console WLS admin, WLS admin. Right, here we go. So we have seen servers so far, and we've seen this startup shutdown classes yesterday, I think. Now we're looking at clusters here. Now this cluster is pretty much alright, what we have seen, we looked at. Apart from what is happening inside, there are certain other things that we will need during the cluster setup. I'll just show you what we need, and then we will go why we need those kind of things. So let's say we give some name to it. Any name you can give, encode cluster 1. Then this is one thing that we will talk about, the messaging mode. The messaging mode is how the members of a cluster will communicate with each other. There are two modes that the members will communicate with each other, multicast and unicast. We will see about these two things in a couple of minutes. So let's say now you select the default one, unicast. That's the recommended one. This was introduced in 9.2. Multicast was the original one, which was available till 8.1. In 9.2 onwards, unicast is introduced, and this is the default recommended selection. Now if you have unicast, you can use, this is basically a one-to-one communication. One member of WebLogic cluster will communicate with the other member of WebLogic cluster using the IP port of its own. Or else we can create another socket which is called a channel here. That can be used as a broadcast channel. Means if there is a common information that everybody in your cluster know, then you will be using a broadcast channel. Like let's say, what are all the servers that are available in this group, because that's some information that needs to be updated at every frequent intervals so that we know the available servers. Now that kind of information need not be passed on from one point to other. It can be simply broadcasted to all the servers. That is usually done by what is called a cluster leader. Now a cluster leader actually keeps a list of all servers available in the group, and the cluster leader will broadcast it. Now for the broadcasting, this is what is used, the unicast broadcast channel. Channel is nothing but a socket. So basically, an IP port combination, we will have and any of these members open up a port, and they will be listening on, everybody will be listening on that broadcast channel. So all the common information will be broadcasted. One-to-one information will be communicated on a one-to-one basis.
Anil, sorry, I could not understand that part. Can you please repeat? I can understand the unicast and broadcast perhaps, but can you explain what exactly this channel does?
I'll come to that point. I'll come to that point in a moment. Let me go to a diagram, and then I'll be able to explain further. So here, let's create this. Now broadcast channel is not really a necessary, let's say, okay, let me go back and I'll explain, then I'll come back here. Just a minute, let's give me a minute. me take up some paint or something. Okay, look at this diagram. This is a multicast model of communicating among the members. If you see, the blue boxes here are managed servers. Let's say they are all in a cluster. In a multicast addressing system, you have a common interface like IP port 239.192.0.1 with a port number. This is just a socket, or it's also called a channel. A channel is nothing but a socket. That's how it's additional one more word to confuse us, kind of. You will see that actually that message during the log itself. See this one here. See, channel default is now listening on this thing. So it's actually the socket. This socket is called a channel, and channel has a name, in this case default. Now we can open multiple IP ports so that a server can listen on multiple number of ports. Each of them will become a channel. So which means I can make one of my JVMs listen on multiple IP ports, or in other words, listen on multiple channels. Now the channel can be used by everybody so that all the commonly sent out messages in a group can be sent on the channel instead of a regular IP port. Now let's say if I have 20,001 is the regular IP port that this server is supposed to use. Now I'm going to configure this server on another port, let's say 20,050. This server is listening on 20,001 and 20,050. Now 20,050 is used by, let's say, everybody as a broadcasting model. Now everybody is listening on 20,050 on that IP port. Now all the commonly sent out messages will be on 20,050. All individual messages will be on 20,001. That way, broadcast channel is, let's say, it's a pretty simple concept. Let's say we are 5 guys running on a jungle. You have a wireless, which is everybody can listen to any message that you talk, and you have a mobile phone, each of you. Now if you want to talk to one of the guys, you will pick up the mobile and call that person and just give that message. Others will not know about it. Now if you want a message for everybody, you will speak it on the wireless. So that's the difference here. So in a unicast mechanism, you have a broadcast channel versus a one-to-one channel. One-to-one, you pick up the mobile, talk to that person. You're done. Only message is between you and the other person. Others need not involve into that one. That's kind of, you are reducing the noise. Then there is a wireless where all commonly needed messages will be communicated.
So Anil, it means if say I have 5 managers, 5 managed servers, one admin and 4 managed servers, I have total 5 servers, and they of course will have a dedicated port which has to be different. So we have 5 different ports, right? These will be the individual channels of communication, and then I will have a 6th port which would be used as a
common
as a channel.
That's right.
As a channel. Sorry, broadcasting channel.
Broadcast.
So I have to define or create that 6th port, and which is more kind of announcing to everyone.
That's right. That's right. That's right.
Okay.
That's correct. One moment, give me one. Okay, so we have a unicast wherein members can communicate one-to-one individual messages, and then members can communicate using a broadcast channel. As opposed to that, you also have a very simple Wi-Fi system where anybody can talk to anybody. In that case, there is no the mobile phone stuff wherein individuals can talk to each other. In a multicast system, you have a series of addresses that you can use. They are called class D IPs. So in this range, you will be picking up one of the IPs, 224.0.0.0.2 239, 255, 255, 255. These are all virtual IPs. That means they are not assigned to any system. That's why they are called virtual IPs, but available on the network. So one of those IPs we can be using, and on that IP port all the cluster members will be listening. Now the problem here is we need to make sure this IP port combination is not used by another cluster in your LAN. Means if there is another cluster here, and if that cluster starts using the same IP port, which means let's say a group of anybody, a group of Telugu guys in one cluster and a group of let's say another Marathis or Gujaratis in another cluster, they both are using the same frequency. Now they will jumble. Means the cluster, you are simply sending a message on top of to this server or to this IP port. Now this is not going to distinguish between who is sending the message. It simply receives a message, everybody else is listening on it. Now you need to make sure, as a network administrator usually ensures that one port, IP port, or one virtual IP port used by a cluster is not used by another one. So what we usually do is we set up a cluster, we use a specific IP port combination, and we notify the network administrator that this is something that we are using. Now anybody else who may be using a cluster in that network will simply check with the network administrator. They will see what are the IP ports currently in use. They don't use it simply. But that's something that we have to take care as our overall infrastructure. But even if something, if somebody accidentally puts up a server on the same IP port, you will see a lot of garbage in the logs. And when you see a lot of garbage in the logs, you will see messages like, I could not understand this message. So one of these managed servers will be telling you, I can't understand a message I received. Now ideally it should understand every message it receives because they are all members of the same team. The moment it starts not understanding something, it means somebody else is sending out a message. Then we have to check out who is sending out the message, where the message is coming from, all that stuff. We need to probably include your network administrator along with your investigation. But in a general perfect scenario, you have either unicast or you have a multicast. A multicast is a very simple technique. You have a common interface, everybody listens on it. So if this server has to send out a message, so it's simply, if this server has to send out a message to, let's say, this one here, this one wants to talk to this one. In a unicast model, it would be something like this, directly talk to each other. But in a multicast scenario, so what we have is this server sends a message to the multicast address. So this one. Now here everybody will receive the message. This server will receive the message. This server will receive the message. This server itself will receive the message because it's also listening on the same IP port. Now depending on the destination or the destination address, because in the message you will have a destination address. Now if it is addressed only for this server, then only that server will process the message. The rest of the servers will ignore it. That's a common mechanism used in a multicast. Whereas in a unicast, there is a common mode of communication. Then there is a one-to-one mode of communication also. So usually what happens is in the unicast, I don't have a diagram here, but unicast, as I told you, there is a one-to-one, which means you and me can talk to each other. But if I have to send out a common message to everybody, now the question is, who is going to send that common message out? Let's say there are 20 servers in a cluster. Now out of the 20 servers, 15 are live. Now these 15, when they need to talk to one another, they are talking to one another individually using a unicast one-to-one. But somebody has to tell about, okay, there are only 15 servers available and this is the list of servers. I say that's the communication we want to pass on to all the 15. that's a broadcast kind of message. Everybody will need to know that one because they need to select the secondaries, all that stuff. Now the question is, who is going to send such a message out? Now that who is going to send such a message out is usually called a cluster leader. Means every server will communicate with the cluster leader is usually the first server that comes up in a cluster. If you have a 20-member cluster or a 10-member cluster in a domain, out of those 10 members, the first server that is coming up becomes the cluster leader. Now that takes up the responsibility of distributing these broadcast messages to everybody. So all the servers will simply send out a common information. Let's say I am one of the members of the cluster. I will simply call my leader. I'll say, okay, I'm alive. Please notify it to the rest of the guys. Like that, all the 20 members in the cluster will talk to the cluster leader. They communicate the message. Then the cluster leader will distribute the message to everybody else. Okay, this is the list of servers available in our cluster. This is a list of live servers available in the cluster. So that kind of broadcast message will be going out at every frequent intervals, every periodic timing. That way all other members know who is available, who is not. So here for broadcasting things you need a cluster leader. I'm sorry I don't have a diagram for this one, that would have much better. So the leader, now the problem with such mechanism is, or especially with unicast is, now assume you have a very large cluster. The moment you have a very large cluster, everybody will try to communicate with the leader. A leader is expected to send out the broadcast message to everybody, which means the load on the leader will increase drastically as the cluster size grows. So a unicast modeling is appropriate for a very small cluster. The moment you have a very large cluster, you always have the danger of the leader going down. Now the danger does not stop there. As you have, as Deepak was telling last time, if one server goes down, the ripple effect will fall on the next server. Obviously, the moment the leader goes down, the next server that came up or the senior server will become a leader. Now that leader also will have the same problem. That will go down. Then another one will become a leader. That will also have the same problem. So the ripple effect will usually shut down the entire cluster, because one leader after the other will go down because of the load. So unicast model is not appropriate for a large cluster. It's appropriate for a small cluster. So you have both the models at this point of time in WebLogic. Multicast is when you have large clusters. Unicast is when you have small number of members in a cluster. Now normally in a WebLogic environment, because we have a restriction like you cannot have too many servers in a domain, usually a cluster cannot move outside a domain. Means in a sense you cannot cluster members outside a domain. It's not possible. And within a domain you cannot have more than 20-25 servers. So it's always the unicast that you will come across. What's the question here? Leaders will be available in both messaging modes. No, there is no leader in multicast. Multicast, nobody is a leader. Only unicast will have a leader. Multicast, everybody is sending it to the same address. So any message, everybody will listen. Even if I have to talk to you alone, I cannot do that in a multicast model. There is no such one-to-one channel available in multicast. I still have to talk on the common address. Everybody will listen to our conversation, but I will simply address it to you. Janara, this is a message for you, kind of. Everybody will be able to listen to it. Multicast, no leader. Unicast is when you have a leader who will distribute the generic messages that are needed for everybody. Now, as I told you, so just to recollect the point, unicast is for a small cluster. Multicast as the cluster size grows. Now let's go back to that creation of the cluster. So here, give a name to the cluster, a messaging mode, what kind of messaging mode we are using. Now here, a unicast, after unicast, it's not necessary that you have a broadcast channel. If you don't have a broadcast channel, the cluster leader will communicate with all the servers individually. So it's an optional setting if you observe it here. All this setting is an optional setting. Even if you don't give anything, it will still be a cluster, it will be still a unicast. In that case, there is no common channel available. The cluster leader will receive all the messages from everybody, and the cluster leader will communicate with each of the members individually. There is no channel in that case. If you have multicast, then obviously you have multicast address, multicast port. See this one? So even in unicast, it's not necessary that you have a common mode of communication. It's always, it can be completely one-to-one. Even for the commonly sent out messages, you still will be using one-to-one. The leader will receive all the messages from individual servers. The leader will communicate with other members individually. So that way you can set up a cluster, and then let's say you click on OK. Your cluster setup is pretty much done. This one. That's a setup of cluster. It's unbelievably simple for some reason, but the actual concepts are inside. Means why we are setting up a cluster, or if there are any problems, especially with the replication, you might have problems if you are setting it up. Now you should understand how the replication actually happens that we discussed. Now when you are setting now you have a cluster which is empty. You have defined a messaging model for this cluster. All that you have to do is get into this cluster, add servers to it. So get in there, click on it. Then you have what is called servers here. So there is a tab servers here, servers tab you have. Click on the servers tab. You can add certain servers. So add servers. Now if you see the servers, this is a drop down list, means this drop down will have servers only from this domain. That restricts us. This cluster can have members only from this domain. A cluster cannot go beyond a domain. Now obviously you can select any number of servers you want. So select this, move on to next. So that's added. Similarly, you can add as many servers as you want, as long as they are from the same domain. So they can be on different boxes. You can still add them because they are part of the same domain. Let's say I'm putting all the 4 servers in this thing. That's added. Now I've added all the managed servers, but when I try to add the admin server, it will throw out an error. So this one. The server selected is currently running. Our admin is running and cannot be added as a member of cluster. Now why it cannot be added? Why it cannot be added is a WebLogic cluster actually does something other than what we have seen so far. It does what is called a GMS level clustering. I think we will understand more about it during GMS. In GMS, we have certain services that can be available only at one point. They're called singleton services. Let's say there are 3 members in a cluster A, B, C. A is offering service 1, B is offering service 2, C is offering service 3. So only one point the service 1 is available, only one point service 2 is available, only one point service 3 is available. Now the services are such services that they cannot be put on another service. Means you cannot have S1 on server A, server B, server 3. It's not possible. That's the nature of this, because of the nature of the service. They're called singleton services. We'll come to those services in GMS. Now in such a setup, a request can land anywhere. The request can land on server A, server B, server C, anywhere. So here if I, let me take a diagram kind of thing. So here, alright, so what we have here is service A, server A, server B, server C. Now server A is offering service 1. Let's say it's offering service 1. Server B is offering service 2. Server C is offering service 3, like this. Now we cannot have all the 3 services on a single server. There is a restriction. For now, let's assume that such a restriction exists. Now the request can land anywhere. So if you see here, assuming you have some kind of a load balancer or something, a request can land on any of these servers. So it can land here, it can land here, it can land here. Now the request can be for any of the services. Assume a request landed on this server, but the request was actually for service 3. Now obviously service 3 is not available on that server. That server is supposed to redirect it to another server, which is the last one. So here in this case, if you see, so this server does not have S3, so it's supposed to redirect it to this server. This is where it should be coming. Now for the redirection to happen, server A should know that S3 exists on C. The same way, server 3 or the last server, if it gets a request for S1, it's supposed to redirect it to the first one, which means the third one should know about the services offered by the first one. So here we are talking about a group. Each of us has a service. Now the requester can come to any of us. They can ask for any request. Now let's say we 3 are offering 3 services. I'm offering service 1, Deepak is offering service 2, Chana is offering service 3. Now a request came to me for service 3. Obviously I don't have it. I have to pass it on to Chana. For me to pass it on to Chana, I should first know that the service 3 is available with Chana, which means each of us should have a list that says who is offering what service. So I'm simply putting up a list. Anil is offering S1, Deepak is offering S2, Chana is offering S3. Now the list is distributed across all of us. Now that list is called a JNDI or a global JNDI. In general, every server has a local JNDI. A JNDI simply tells what are the services offered on this server and who is the person or what is the object that is offering such a service. Now that's a local JNDI. Instead of a local JNDI, what we are talking now is a global JNDI, because we 3 are working in a cluster. When we are working as a group, we have services that are unique to each of us, but the request can land anywhere among us. We should be able to redirect it to the appropriate person or the server which is offering that service. So I should have a list of all the servers with the corresponding services, so that when I get a request, I can pass it on to the appropriate server. Now that list is a global JNDI. In a cluster, the global JNDI has to be continuously circulated, because at point A, let's say at 10th minute, one of the servers went down. Obviously all the services offered by that server should be removed from the list. The new list has to be circulated among the members. Means the syncing of the global JNDI happens at regular intervals. Now that syncing cannot happen, or you cannot get a global JNDI if you are already running. That's why a running member cannot be added to a cluster. So if you come back to this point, why we are talking about the global JNDI, all the stuff. So global JNDI is a common list. Means it simply lists out which server is offering what service. Now that list gets circulated across the members. Now if the server is now when the server comes up, it will actually pick up that list from an existing member. It syncs it with the local JNDI. But if it is already running, which is the case in the admin server, it cannot recreate a global JNDI. It's not possible while it is running. That's the reason an existing server cannot be added to a cluster. So, a running server cannot be added to a cluster. Now in this case, an admin server which is already running cannot be added because the global JNDI of admin cannot be synced with the other members of the cluster. Now what is global JNDI? Why we need such a service? We will come across GMS. We will have a complete understanding of GMS. When we go to GMS, we will refer back to this one again one more time. So for now, just keep in your mind, a running member cannot be added to a cluster. You just have to shut down the server, add it to the cluster from console, bring it up. When you bring it up, it will synchronize the global JNDI with the other members. Now if you see this one, I'll show you the message that actually refers to a cluster member. So we have created a cluster with basically I'm cancelling this admin add up. We have created a cluster with 4 members now. I will try to add or start the server 1. We will see certain messages that actually refer to a clustered server. So this is our admin server. Now let's start the manage server. Manage 1. If you start this server, you will see a couple of additional messages that we haven't seen before. Now those are actually members messages from cluster. You see this error? This is a startup class we have created, but this class is nowhere because we did not add any jar file that has this class. That's this error. So we have added startup class 0. We are given this is the class it needs to execute. When it tried to execute, it could not find this class anywhere in the class path because we did not add any jar file with this class. Now come back again. Now look at these 2 messages. These are the 2 additional messages that you are seeing now, which were not there earlier. Now what these messages tell you is it's listening for the announcements from the cluster using unicast cluster mechanism. That's basically you're talking to the leader or you're waiting for that leader. The second thing, waiting to synchronize with other running members of cluster. Now what is it synchronizing? It's synchronizing the global JNDI. Now these are the 2 additional messages you will see if a server is inside a cluster or is a member of the cluster. Now it's listening for announcements. Basically it's trying to communicate with the leader, but in this case there is nobody else. This is the first server that's coming up in this cluster, so MNG1 is the actual leader here. That will be realized and this will automatically become the leader. Then the synchronization is also not happening. So in this case, obviously, because there is no other server already running. So this will create a global JNDI. When the next member starts, when you start MNG2, MNG2 will contact this server. The global JNDI will be synchronized again. Alright, so the global JNDI has to be created during the startup. It cannot be created while the server is in flight or while it is already running. That's the reason a running member cannot be added to a cluster. Alright, so apart from that, now here you got already cluster members communicate using either multicast or unicast. A multicast is a virtual IP port, a class D IP this is. So the default multicast is 239.192.0.1. That's you can change that multicast status and just notify the network administrator so that others will not be using it. Now the drawbacks of multicast. Now this PPT is wrong here a little bit. Even multicast uses TCP. This is an old one. I think I put it somewhere. So user datagram protocol is not used even in multicast. It still uses a TCP kind of thing. Now the problem with multicast is its second point, the too much network traffic, because you will be broadcasting everything on a in a common channel. So to reduce that multicast, we can go for a unicasting, alright, a one-to-one messaging model. One member will be talking to the other member kind of thing. So when you use unicast versus when you use multicast is when the clusters are small, you go for a unicast. When a cluster as it grows larger, you have to go for a multicast, because a unicast model cannot hold a large cluster. The leader will usually go down if the cluster is too large, and the leader going down will have, it's a cascading effect. It will first server will go down, the second leader also will go down, because the second server cannot hold the similar load. So multicast has a lot of packet loss, obviously. Now if your routers and switches are not configured properly, then you might have problems. And if you are designing a cluster across a router, means not all your servers are within the router, then your multicast may not work. Means that's another additional point that you need to look into. Like when you are working on a WAN, and this is extremely rare that you come across it, but just to put a point, if you are working on a WAN, a wide area network, which means your packets are or your cluster members, all your managed servers are not within a single LAN, they are across the routers. So between one managed server and another managed server, you're passing through a router. In that case, you have to configure the router to actually pass the messages to the other server. The routers may discard your messages because they're working on a virtual IP. Now you need to talk to the network administrator in that case, just to make sure that these two servers can communicate on a multicast IP port. This is only when you have a a WAN cluster. A WAN cluster is very rare because of the problems that it will have, especially the packet loss, and routers have to be configured specifically to communicate on the multicast. I'm not going too deep into that part. That's really advanced, but you will get a hang of it if you need to. The basic, the regular clustering stuff would be enough for us. If your fundamentals are right, you will get WAN stuff. That's not a very big deal. Then there are a couple of other points about clusters. So usually you don't put your admin server into a cluster. Obviously it cannot be done from console, because the admin is already running by the time you open up a console. And if the admin is already running, it cannot be put into a cluster. But there are other ways of doing it. Obviously you can edit the config.xml. You can put admin server also into a cluster. And if you ask me, is it possible and is there a way to do it? Yes, there is a way to do it. Not from the console, but go to the config.xml, add your admin server also to the list of servers in the cluster. But that's not usually recommended, because we don't have any application on the admin. That's something that we already have in place. So if you don't have an application on the admin server, why would you want to put it into a cluster? It's not going to be functional. The second thing is it can spread across multiple boxes as long as the servers are in the same domain. So your domain can spread across multiple boxes, so you can put any server from the single domain into a cluster. And the second thing, there can be more than one cluster in a single domain, no issues. Another point here is a server cannot belong to multiple domains. A server cannot belong to multiple clusters. Means if you go to the console here, if you have encode mng1, it can belong only to one cluster, encode cluster 1. If you create another cluster, encode cluster 2, and if you add mng1 to that cluster, it will be deleted from this one. So if you want to do it quickly, so let's say you go into clusters, you create a fresh cluster. Encode cluster 2, let's say. Unicast we are using, so no issues. Okay. So you have second cluster. Now let's add a server to cluster. Go into servers. So quickly add mng1. Now because we have one added, the server is running. Let's add two. See, the server is running, one is running already, so we can't add it. Let's add two. So you have added two. Now once you have added two to second cluster, it would be gone out of first cluster. Let's go back to first one. First one, servers. You don't have two anymore here. Alright, so a server can belong to only one cluster, and a domain can have multiple clusters. Now there is one more thing that you usually come across, a cluster address. A cluster address is a very simple thing. It's a comma separate list of its members. So if you see it here, if there are 3 or 4 servers, all that you have to do is separate the IP port of each of those members using a comma here. That's it. So here I missed the port number here, but it's IP port of everything. Now this IP port can be configured in your DNS. Means you can map it. Let's say mycluster.mycompany.com. Now that URL can be configured to send it to any of these server IPs. That's one thing that we can usually do. Means cluster address need not be a list of IPs, IP port numbers. It can be a URL also. A URL mapping can be done in DNS. So that's something that you will come across in real time. Means it's not always a IP port combination. But it's IP port combination, but that need not be the way you always refer to it. You can refer to it using a URL also, but if you are planning on doing that, you have to map it in your DNS. I've added this point because you will come across it somewhere, cluster address. So it can be URL. You just have to ask your DNS team to configure it. Now this point we already referred to, waiting to synchronize. It's basically synchronizing the global JNDI. Alright, so that's your WebLogic cluster. Now basically I'll just summarize everything. Now WebLogic cluster is for high availability, and high availability we achieve by implementing session replication. Session replication on WebLogic front. So you will replicate it across primary and secondary, this thing, and the load balancer is the one that redirects primary and secondary. If primary is available primary, secondary is available secondary, and load balancer has what's called a session stickiness property. Then you got two types of replication. You can replicate in memory, or you can replicate into a database. Either way, the replication, if it is in memory, it's faster. If it is database, it's more like a permanent or guaranteed replication. Again, the cluster creation of the cluster is, it can be done from console. You cannot add a running member to a cluster because you cannot synchronize the global JNDI. Now the clusters will communicate among themselves. The cluster members will communicate among themselves in two modes. You got unicast versus multicast. Unicast is one-to-one. Multicast is on a common interface. Everybody will listen. Now when you use unicast is when your cluster is small and there is a cluster leader concept. As the cluster goes, it grows to a larger size, then you should move on to a multicast. Alright, again, a domain can have multiple clusters, but a server can belong only to one cluster. Those are some of the very the crux of your clustering. Now if you have any questions, you can. Any questions? Otherwise we are done for today. So